Well, thank you for checking out the Virtual Airtable program. We'll just do a quick little review of what the menus and what options the program has. It makes it a little easier to work. It's quite lots of options available, so we'll just quickly go through some of the basics. First off, we've got a whole bunch of experiments sort of built into it, and you can sort of play around with the values and see how things work in the general setup. You can actually create a collision and save it, or you can load it. The other nice little feature is you can actually copy a collision and be able to put it into a Word document. Some of the things available that you can do is you can do a 1D or 2D collision. You can even have one or two mass. You can trace the center mass of the objects or trace the actual centers. And what centers you actually do want to trace can be listed here. So you've got before and after the collision. You can show some direction arrows, which are really ideal when you're copying into Word documents. So you can show the direction the object's going in, put the scale in, show grid, and you can actually label the masses if need be. Some of the options also involved, you can do a 1D spring, whether it be an elastic spring or an inelastic spring. Likewise, you can just do a typical billiard ball type collision where it's elastic, inelastic, or semi-elastic, or partial. You can also do it with an electrostatic forces involved. You can do unlimited range, so it's always having repulsion or attraction, or you can set the range. You can also do circular motion with it, and as well some other the basic options, which aren't too bad. So here, just to do a quick example, we can go through a typical collision where we've got masses, equal masses, one object moving, the other one not. Since it's an elastic collision, we can actually bounces off directly. We can quickly reset it. I can change it to an inelastic, so after they will actually go and say stuck together. Likewise, we're able to go and do a semi-elastic, and I can decide what type of collision I want. I can actually turn it into an explosion, so when they actually go and collide, energy is actually added to the system. Likewise, I can reduce to the degree that I want the collision to have. And if I almost make it a total inelastic collision, when they collide, they almost stay stuck together, so it sort of follows it behind it. If I leave it long enough, you can actually see the separation. Then if I actually go to the option showing a spring, we've got the object going collide. There, the actual collision lasts a little bit longer. And likewise, if we go to an inelastic and they go and start, they stay stuck together. Likewise, after the collision, you can actually go do some analysis to it, where you can actually show the speeds, the angles that they're at for a 2D collision. It's handy. You can see the energies before and after. You can also work with momentums. You can actually show the spring compression about how much it was compressed during the collision. You can actually copy all that data, put it into a spreadsheet, or once again, you can actually highlight it and just copy the selected. You can see the graphs before and after the collision, whether the component analysis or scalar analysis, and you've got the energies, momentums. You can show which ones you want to see. The other really handy one, it's more useful for two-dimensional collisions, is you can actually analyze the motions before and after the actual collision. Anyway, a neat little program. I'll probably be adding more videos showing you how the two-dimensional collisions work and some of the really cool features that's involved in that, and how you can actually do the analysis and change various ones. Anyway, I hope you like the program, hope you check it out, and let me know what you think in the comments. Thank you very much.